Talk about some more triangles, and we're going to talk about things being in proportion. But this is actually, I think this section right here is just a little bit easier than like the similar triangle thing. I really believe it is. And you tell me at the end if it is or not, okay? People always accuse me of lying when I say that. When I say, Mr. Henry always says this is really easy. I'm like, maybe I do sometimes, but this one really is a little bit easier than I think what you've done before. So here's the situation. We have a triangle, and let's say one of the sides, or what we're going to do is we're going to make a line in that triangle that's parallel to one of the sides. All right, so let's just start here and connect here to here, and we'll make it parallel to this one right here. Everybody see that? Now, if it's truly parallel, we'll put a little arrow there. Okay? And you've actually seen these before. You had a homework before where you actually had this. Remember we separated them? Remember that? We pulled the little triangle out, and we pulled the big triangle out, and then we saw the relationship between the sides and all that kind of stuff. Right? But this makes things a little bit easier. What we had to do before, though, before this, we looked at similar triangles, and we compared the entire side of the triangle. So we took this left side of the little triangle, and we compared it to the entire side of the big triangle. Do you remember that? Then we took the right side of the little triangle, and we compared it to the whole entire right side of the whole entire big triangle. But we're not going to do that today. If you look at this parallel line and this parallel line kind of break this side up into two little segments. Do you see that? See this little segment from here to here? Let's just call it A. Is that all right? Everybody see what I'm talking about when I say to A? It goes from this point to this point right here. So that segment we'll just call side A. Now we could put, big letters A, B, C, D, E, F, G, or whatever, and then say this is side AB and this is BC. But it's a little easier just saying this little segment right there is A. Would you agree? All right, so let's make this segment from here to here. Let's just make that one B. Everybody got it? And what about this one? Let's make that C, and then make this little one D. So the D is not the whole side, is it? The D is just the little bit from here to here, and the A is not the whole side of a triangle, is it? It's just a little part of the side of a triangle. So we've got our sides kind of labeled right here. Now watch how easy this is. I promise you. Okay, watch how simple this is. We can make some ratios, and we got a proportion going on here. So I can compare this segment to this segment. We can compare A to B. But how do you think we're going to compare it if we go to the other side? If I compared A to B, what do you think we're going to do over here? D to C. Everybody see that? Now, does that mean that A and D are equal to each other? No, it doesn't. Yeah, D does look bigger, okay? But if I made a ratio of D to C, because look at this. This D looks a little bit bigger than the A, and this C looks a little bit bigger than the B, doesn't it? But it's the same amount bigger, okay? This is the same amount bigger than this as this one is to this. Does that make any sense? I don't know if I worded that right or not. But if I compared A to B, what am I going to do over here? D to C. All right? And that's our ratio. What do you think they're going to do on the homeworks and that kind of thing? What are they going to put in here? They're going to put numbers in here, right? Or X's, right? They're going to put some numbers in here. They'll probably give you like 3 of these, and you have to find the 4th one. What would you do? What kind of math would you do to get cross multiply? Exactly. They'll give you 3 of the 4 things that you probably need to know, and you're going to cross multiply, solve for the missing thing. Pretty simple, isn't it? Would you agree? Yeah, absolutely. So if I went A to B, I'd have to compare D to C. Now you could go the other way, couldn't you? I could compare, watch. If I wanted to, I could compare B to what? A, but what would I have to do over here? Compare C to D. Everybody see that? Now, how do I know if they're the same or not? I'll show you. If you cross multiply, they should be the same thing, right? They should be in proportion. So watch. If I cross multiplied this and this, I would get what? AC equals BD. Do I get the same thing if I cross multiplied over here? Yeah. I absolutely do. If I cross multiply, look what I get. I get AC again equals, look, BD. So they are exactly the same. So I can compare both ways, can't I? I can go A to B equals D to C. Or I could go B to A and it's compared to C to D. Or let's think of it this way. Let's call this the left side. Let's call this the right side. This B, let's call it the top left side. Everybody see that? So this is the top left. What am I comparing it to? The what? The bottom left. Do they have anything in common? Top left, bottom left. They're both on the left. Agreed? All right, so I can compare them like that. What about the C and the D? This is the what? The top right, and this is the bottom right. What do they have in common? They're both on the right. Okay. Now, there's another way that you could compare them if you wanted to. You could compare B to, what do you think? C, and then you're going to compare what? A to D, and exactly right. B is the top left, C is the top right. They're both on the top, so you can compare them to each other. Make sense? What about the A and the D? They're both where? On the bottom. So this is the bottom left, and this is the bottom right. They're both on the bottom, so I can compare them to each other. What do you think is a way that you can't compare them? You can't go B to D, because look at B and D. B is on the top left, and D is where? On the bottom right. Do they have anything in common? No, they don't. So you can't compare them. So that's a nice, easy way to remember. Does that make any sense? Yeah, and that's pretty easy. I think it's kind of easy, don't you? You don't have to worry about like comparing this left side to the whole entire left side, and the right side to the whole entire right side. You can just compare the segments to each other, which is kind of nice. We good? All right. Let's do another thing with the triangle here. I don't know, did I copy a triangle? I sure did. Let's do another one. We'll use the same triangle. And we're going to introduce another word. And we've actually used it already. We used it with a trapezoid. What if we did this? What if I took the midpoint of two of these sides? I don't care what two sides. Let's just use the left side and the right side. What if I found the midpoint of the left side? That would be about right there, wouldn't it? And let's find the midpoint of the right side. If I scooch this over to about right there, that would be the midpoint of that side, wouldn't it? Oops, let's go to the pen. There we go. And if I connected them, well, it's pretty close. There you go. That's a little better. All right. And I connected the two midpoints. Everybody see that? So I connected the two midpoints of the side of a triangle. Now, I mentioned a second ago that we did this with trapezoids. Do you remember we doing that with a trapezoid? Connected the midpoints of the opposite sides? What did we call that thing when I connected the midpoints? Right, it's called the mid-segment. Well, guess what? We also have a mid-segment. That thing right there is called the mid-segment. Write it down. It doesn't look what? You're mumbling. I can't hear what you're saying. It doesn't look like it's in the middle? Well, it sure is. Watch. Look, if I clicked on that, see how that dot's straight across from there? Okay, and that dot straight across from there? Yeah, I would say it's in the middle. All right? I mean, that's fairly accurate. Not dead on, maybe, but I mean, it's fairly accurate. So this is called the mid-segment. Do you remember what was true about the mid-segment of a trapezoid? Remember doing this? We put two things. What was the first thing? Jada, what was the first thing? Okay, it was the average, but that was like the second thing that we talked about. We talked about something first before we said it was the average between the two bases. We said it was, what does this line look like compared to this line right here? Parallel, exactly. So that was the first thing that we said. And I'm going to go ahead and put some letters in here now. A, B, C, D, E. All right? So the first thing I can write down would be what? That BD is parallel to CE. So that's the first thing we know. Everybody with me on that? And we just finished doing a thing about having a parallel line inside of a triangle, didn't we? All right. Now, what's the second thing do you think you might know about this? Now, remember, Jada said this was the average, right? So remember on the trapezoid, we had a top base and a bottom base. We added them up, divided them by 2. But do we have a top base up here, though? No. So what do you think? Going from that trapezoid thing, what do you think might be true about line segment BD compared to line segment CE, the length of them? What do you think? Now remember, this was, right, this was half of the sum of the two bases, right, on the trapezoid, but this base doesn't have a base. It's just 0, isn't it? So what do you think it is then? It's just half of this. Exactly right. So when you have a triangle and you have a mid-segment of the triangle, if I connected the two midpoints, this mid-segment is exactly half of CE. So if I said that BD was 5, what do you think CE is going to equal? It's going to be 10. Pretty easy, right? And if I told you CE, you would just take half of it and get BD. Everybody got that? That's not hard, is it? So I wasn't lying when I said it was kind of easy, did I? All right, so how would we write this? We would say that BD equals, right, the length of BD is equal to what? Half of the length of CE. All right, so those are two things that we know about this. When we have a mid-segment, that mid-segment is parallel to the opposite side, and it's also half the length of the opposite side. Everybody got it? Yeah, pretty easy stuff. All right. Let's do some. I tell you what, let's do an example. How about that? Let's do an example before we move on to the new stuff. Well, the newer stuff after this. So write this down. Here's a triangle. Looks like this. I'm going to make it an obtuse triangle. I'm taking this right from the book. This is R. Actually, let's put some stuff in here first. Watch what I'm going to do. I'm going to put two mid-segments in here. So I'm going to find the midpoint of this side right there. Okay, and then I'm going to find the midpoint of this side, and that would be about right there. And I'm going to connect them with each other. Hopefully, yep, right on. And there we go. So that is a mid-segment. So what's true about this? It's parallel to that side right there, isn't it? If it's a mid-segment. Everybody with me? All right. Let's do another mid-segment. And they do the mid-segment between this bottom side and this long side right here. All right, so let's find the midpoint of this side. Well, that's easy. It's right there where those dots are. And I already found the midpoint of this side over here, didn't I? So what happens if I connect those two? What do you think's true about that? It's parallel to this third side right here, right? That it wasn't connected to. Everybody got it? All right. And let's put some numbers in and let's see what we're going to try to solve for here. They say this angle right here is 124 degrees. They say that this side is 7, right? From here to here is 7. And they tell you the whole entire bottom of this thing is 13. From there to there. Okay? And they label it. And I started labeling it earlier. So let's finish it up. That's a Y. That's T. This is Z. S. And X. All right. Now, here's what they're going to ask you to do. They're asking to find three things on this particular problem. The first thing, they want you to find the measure of XZ. All right. The second thing they want to find is ST. And then the third thing is an angle. It's angle RYX. RYX. All right. Well, let's change it to blue now. Okay. So let's start with this XZ. Let's take a look. This is what we're trying to find right here, isn't it? I'll tell you what. Just so it stands out a little bit, we'll make it blue. We good with that? So we're trying to find that blue one right there. So what do you think? Any ideas? It's what? Is that angle going to have anything to do with the length of this side right here? Not really. Is it 13? It's half of 13. That's right. It's half of 13. Why is that? Because the mid segment is half of that third side, right? See how it connects these two sides right here? Well, the side that it doesn't connect, it's going to be half of that. So if this is 13, this blue one right here has to be half of 13. What's half of 13? Yeah, 6.5, 6.5. So watch. You know how I kind of get on your case a little bit about showing work? Well, here's how we show work. All right, it's very simple. It's not that big of a deal. It's just 1/2 of what? 13. Half of 13 is 6.5. So that's what I'm talking about. When I say show work, that's all I'm looking for, okay? It can be very, very simple. It's not always long and drawn out, right, the showing the work. Sometimes it's pretty basic. Everybody with me on that? Okay, good. Let's do ST. ST. That's this big old long one right here, that whole entire side. Let's make that a different color. We'll make it like this purple color. All right, so we're trying to find ST. Well, look at that. That's not a mid-segment, is it? But do I know a mid-segment to this side right here? Yeah, it's the 7, isn't it? So this is the mid-segment because it connects these two sides. This is the one side that's not being connected. So this has got to be the mid-segment of this big purple one. So does that mean this purple one is half of 7? No, it's what? It's double, right? If the mid-segment is 7, the third side, the opposite side, has to be double that. And that's just pretty easy, right? So it's just what? 7. What's the work? 7. Well, you can just times 2. You could put plus 7 if you wanted to. I think it's easier just putting times 2, and that equals 14. So that whole thing right here is 14. Told you it was easy, didn't I? Yeah, I wasn't lying. What about this one? This RYX. RYX. Well, let's find RYX first. Here's R, here's Y, here's X. So it's this angle right there. That's what we're trying to find. Now, if they ask for an angle, what's the first place we're going to go to? Probably go to that 124, right? And see if there's any relationship between this angle and this angle right here. Is there? They are, exactly. Because look at this XZ, this blue one right here. We'll put a little line to represent that one. Look at this bottom one, RT. We'll put a little line to represent that one. And then this XY is a transversal, isn't it? Am I right? So isn't that what we have without all the junk all around it? Yeah. I think it's kind of nice to do this off to the side if you need to. If you get too confused, if there's too much stuff all around, separate it. Take that side and this side, and you say, okay, I got two parallel lines, right? I got two parallel lines cut by transversal. Where's the 124 in this picture right here? That would be right there, wouldn't it? So if that's 124, and we're trying to find this angle right here, is there any relationship between this angle and this angle? Yeah. Alternate interior angles. Very good. Okay, they're alternate interior angles, so that's got to be 124 as well. So that's our answer right there. No math involved, was there? Just had to recognize, though, you had to see the relationship, recognize that they're parallel lines cut by transversal, and that's 124. And we're good to go. You okay with that? All right. It's not that hard. The math was easy, wasn't it? Half of 13, 7 times 2. Come on. There's no math on that at all. The math was easy, but it's finding the relationships. That's always been the hard part of geometry, hasn't it? This year, it's not really been the actual math that we did. It's putting the stuff together and finding out, are they equal to each other? Do they add up to something? Do we subtract this from something? Yeah, that's the part of geometry that's a little bit tough. The math was always pretty easy, I think. I think you could agree with me on that, right? But the hard part is understanding the relationships between the angles and the sides and all that stuff. All right? There we go. Let's do another type of problem. This is not an example. We're just going to go through this. Now, we've talked about triangles. In fact, the other section we talked about triangles. In fact, I think almost this whole entire chapter so far we've talked about triangles. But this time we're not going to talk about triangles. We're going to talk about some parallel sides or parallel lines. So watch, I've got a parallel line here, I've got one here, and I've got one down here. I purposely put a big gap in between these for this one. And let's put some transversals in here. So I got a transversal here, and I got a transversal here. And they're at different angles. Now let's see what I've got here. It's very, very close to the first thing we talked about today when we talked about the that parallel line inside the triangle. Remember that? It broke it up into those segments. Well, this is also broken up into segments. Look at this. From here to here is a segment, and from here to here is a segment. Let's just call that A. We'll call this one B. We'll call this one C. It looks like an E, doesn't it? Let's make it look like a C. There we go. And this one is D. And these lines are all parallel. Now look, let's take a wild guess. It's not that wild, okay? It's a pretty good guess. John, what do you think might be true about the relationships between these? It's very, very, very close to the triangle. So what am I going to do? I'm going to compare A to what? I want to make a proportion. I'll give you a hint. I want to make a proportion. What am I going to compare? A to B. Good. All right. It's just following what we did the first time, right? Okay, it's pretty much the same, except what's the big difference? We don't have a triangle, do we? All right, we got parallel lines, but we don't have a triangle because that doesn't really come to a point right here, does it? But the relationship's exactly the same. So if I can compare A to B, everybody should see it now. What am I going to compare over here? C to D. You got it. Make sense? Let's do a couple different ways just to kind of show you that it's going to be the same thing. I could go A to B, C to D, or what's another? Let's start at A. What else could I do? I could go A to what? Yep, I could go A to C, couldn't I? And then what would the other one have to be? B to D. Does that make sense? Or we could go backwards if we wanted to. I could start at B and do what? B to A. And if I go B to A, what's the other one have to be? D to C. Everybody see that? Or instead of going A to C, what could I do? I could go C to what? Look at it. C to A. Right. Instead of going A to C, I could go C to A. What am I doing? I'm just reversing these, right? Just taking the inverse. As long as I take the inverse of both of them, it's the same exact thing. So if I go C to A, this one has to be what? D to B. Getting it? All right. What if I wanted to make sure that they're all exactly the same? Look at it. I could cross multiply. What do I get when I cross multiply here? AD equals BC. Do I get the same thing here? Yep. AD equals BC. Do I get it here? Yep. AD equals BC. AD equals BC. They all say the same exact thing, don't they? That just proves that you could use any of those relationships. What's the one way you can't go? Let's do some different color. We'll do it in this gray. You cannot do this. Don't even write this down. Just watch. You cannot do this. You cannot go A to D. Now, if you go A to D, what would it look like you would have to do next? If I went A to D, it looks like you would go C to B, doesn't it? Let's see if that's true. Does it have the same proportion as this stuff? No, it doesn't, because look, watch. When I cross multiply, what do I get? I get AB equals CD. Is that the same thing as we get here? No, it's not the same thing. So this is not the same as this. So you cannot do this diagonally. Make sense? All right, make sure you don't do that. And I gave you 4 different ways that you could compare them. Pretty basic, pretty simple. We good with that? All right, let's do one more, and we'll be done. And I'll give you a little work to do. I know that's what you've been waiting for, right? That's what I thought. All right, watch what I'm going to do. I'm going to put some more parallel lines, 3 parallel lines, but this time I'm going to try to evenly space them. So what do you think? Does that look pretty close? Maybe I could bring this up just a tad. That's pretty close. All right, and I'm going to put some transversals in here as well. Oops, get the right pen, tool, like that. Now watch this. This is really, really close to what we did before. Just a slight difference. Everybody see this? Now watch. If they told me, now I evenly spaced these together, so what do you think is true? If these are completely evenly spaced, yeah, what do you think this is? That's probably equal to that one right there. Now, does that mean this one right here is equal to this one right here? Nah, because that one's slanted a whole lot more, isn't it? And that definitely looks longer than this one. But guess what? If this one is equal to this, what's the ratio? Doesn't matter what numbers you put in here. It doesn't make any difference. What would the ratio be between them? Is it 1 to 2 between this one and this one? No. Let's just make up a number. Let's say that was 5 and then that was 5 right here. What's the ratio between this one and this one? Is it, what'd you say? 1 to 1. Okay, yeah, it's 1 to 1 because 5 over 5 is equal to 1 over 1, isn't it? So if you have the same thing, the ratio is 1 to 1. Well, look at over here. These are evenly spaced over here as well. So guess what must be true about this? It must have the same ratio, right? They got to be in proportion. They must have a ratio of 1 to 1. So guess what? This one has got to equal this one right here. You see that? Now, again, this doesn't mean that this one's equal to 5. This one could equal like 7. So if this one's equal to 7, what's this one right here? It's got to be 7. Make sense? And that's really the only thing that's different about this one. All right, so if these two are equal, that automatically makes these two equal. You hear that? So if they tell you that these two right here are equal and they don't tell you anything about these two, you automatically know from this little theorem, and it's a theorem that these two segments are equal as well. And you know what they're going to do, right? They're going to put some like x's and stuff like that in there. All right, so let's do an example. We got a few minutes here. So let's do an example that does all that stuff. Let's do this. Copy and paste. Paste again. Let's scooch that about right there. Actually, let's do this. All right. Those are parallel to each other. They tell you they're parallel. You can't just assume it. All right. Oh, wait a minute. I don't want to make that. Let's do this. Get out of that. Now let's go to red. I'm going to put a couple transversals in here. Let's see. This one kind of looks slanted up like this, and this one looks a little bit more straight across like that. All right. And this is what they tell you. They tell you that these two are equal to each other. All right. And they tell you the value of this is 6x minus 5. This is really easy. And I'm not kidding. I'm not just saying that because I'm the teacher. I promise you, these are really simple. Exactly right. All right, here we go. This is the information that they give you. And they ask you to solve for x, and they ask you to solve for y. So if you look at this, look, this segment's already, they tell you that they're equal to each other, okay? They told you in the problem that this segment right here is equal to this segment right here. So what are we going to do to solve for x then? Set them equal to each other, okay? Don't always do that for every single problem, all right? Because that's not always the case. But in this particular problem, it is the case, isn't it? So you can just set them equal to each other. And I'm not going to do the math. I did it in the other class. If you really need to see it, you could go to their video. You can listen to me yell at them for a couple minutes, and then I do this, okay? And then what about these two down here? If these two are equal, and then you just solve for x, all right, whatever that is. I don't know what it is. You said it's 4? Yep. Yep, subtract 2x, or 4x, you get a 2, and that's an 8, and that's divided by 2, it's 4. Very good. What about this one right here? Now, they don't tell you that these two are equal to each other. Can you still set them equal to each other? Yeah, why? Mary, you shook your head. Why? That's right, because these top ones are equal right here, so that means that these are automatically going to be equal to each other as well. Right? That's the thing we just talked about. And so what are you going to do here? You're going to set them equal to each other, and then you're going to solve. Subtract 5, that's a 2, that's a 15. 15 divided by 2 is what? 7.5, right? Or you could just write it, or you could have just kept it 15 over 2. I wouldn't care how you do it. And there you go. Simple as that. We good? All right. What do you think? You like this section? Yeah, it wasn't hard, was it? Just seeing the relationships between them? It wasn't hard at all. So I'm going to give you actually 2 worksheets since we had a free day yesterday. Well, we kind of had a free day. Free day of math, right? But we still learned some stuff, didn't we? Hopefully. Hopefully you learned some stuff. Hopefully you'll remember that even more than what you remember your math, I hope. I think it's, what is it? Yeah, it's pages 89 to 90. Okay, so it's 2 worksheets. It's the same section, all right? It's still section 7.4, and then you're doing pages 89 and 90. All right, that's it, and so that will be due on Monday.